This problem is similar to a recent SMO Open problem. And after you see the way this problem goes, you may prefer the term between. They use the term bounded. It's slightly ambiguous no matter what you use here, I think. So everybody has if you have any familiarity with the shapes of these graphs, you know what they mean. But a priori, this may be slightly ambiguous instructions. But this is roughly the instructions they used on this test or this competition exam, whatever you want to call it. Now, all of you recognize this as an area of a circle, and it's very easy to identify the critical values or points on the graph. Certainly, 0, 9 is a point on this graph. If you let x equal 0, 9 squared is equal to 81. Okay. And then over here to the right, and this is the the x-axis here, you would have 9, 0. Okay. And then down here, 0, -9. And again, y'all, these are xy coordinates that satisfy the equation that you see of the circle. And then this would be -9, 0 over here. Now, what makes this thing very pleasingly symmetrical? This absolute value equation may not be quite as familiar to most of you, but notice that these 4 points are the easiest points, the intercepts, that satisfy this absolute value equation. 0, 9 is certainly a point on this graph. -9, 0, and so on. You can just tell by the definition of absolute value, right? Now, the shape of the graph is different. You know it's going to be linear. So the shape we're going to have is going to be something that looks more like this. And that's supposed to be a line. Okay, and then down here. So you see we will get I guess a square, right? Squares and circles are about as symmetric as it gets, right? Now, y'all, the region that they're talking about, and I think it's fairly natural to assume it's between or bounded. So we're looking at this, and I won't attempt to shade all of it, but we're looking at all of this right here. Okay, and again, I'm not going to shade the whole thing in, but we're looking at the area that's outside of the square, but inside the circle. Okay, so we're looking for this so-called shaded region here, ladies and gentlemen, okay? And that's very easy from a standpoint of familiar formulas. The area of the circle, let me just let's just write it like this. Very nice just to use symbols here. It's the area of the circle minus the area of the square, right? Very simple visual way to represent this. And so that would be pi times the radius squared, so that would be pi times 9 squared. Okay, put a dot there just for, okay. Now, what about the area of the square? Okay, well, let's see, what do we got here? The area of a square, this distance, let's just draw a picture all the way down to the origin. Y'all, this is 0, 0 right here. 0, 0. Now, the area of any square is just the side. Well, let me write this. S squared, right, where S is the measure of one of the sides of the square. Okay, well, this isn't so bad, right? Because what we have here, what do they call this? An isosceles triangle? 2 of the sides are equal. And so this distance is certainly 9. Okay, we're trying to find S, right? This distance is 9, and we'll call this side, the hypotenuse, S. Well, it's very clear that S squared, let's see here, that would be equal to the square root. 9 squared is 81, plus 9 squared again is an 81, so that would be what, 160, 81 plus 81 is 162. Let's just write this better. We don't need to know what that is. This is just 2 times 81 squared, right? That's better. We don't even need to know it's equal to 162. It's an easy computation. But that means that S, oh, is that what we need to know? Yeah, S squared. No, that's the square root. But this is a 1 times, it's the, S would be this, right? Okay, so what we're going to have right here is we're going to have pi minus 9 squared minus the square of this side, which is just, let's see, the number here, right here, it's 2 times, the length of this side, let me just write it down here, y'all. This is equal to 9 root 2, right? I'm going to way too much trouble here. But so S squared is what I was saying. S squared is equal to, I had it a while ago. I'm going through some unnecessary steps here. But this would be 162, right? Okay, that's what I needed in the first place. I was confused there with my calculations. So anyway, we get this statement right here. So now, sanity check. This would be something like 3.14 approximately. It better be positive, right? So this would be 3.14 times 81, which is definitely a number bigger than that. Yeah, I won't do the calculation right here, but this is your answer, whatever the calculator returns if you need that. But this would be somewhere around what? 3 times 81 is 243. So a number maybe in the 250 range. So it'd be approximately 250 minus 162, and we might as well say square units. Okay, y'all. This is just kind of a mess right here, but this is what S squared would be. So square units. And this is the answer I got, folks. Okay, thanks for viewing.